A certain substance decomposes according to a continuous exponential decay model. To begin an experiment, the initial amount of the substance is 250 kilograms. After 5 hours, 110 kilograms of the substance is left. Let t be the time in hours since the beginning of the experiment. Let y be the amount of the substance in kilograms at time t. Write a formula relating y to t. The strategy here is don't just call it y. We're going to take advantage of function notation. So instead of writing y, we're going to write y of t. So we want to relate y of t to t. We're going to write that relationship. And we already know this. It's going to be a continuous exponential decay model. So y of t is equal to some initial amount, which I will call y sub 0, e to the rt. Now y sub 0 by definition is defined to be y evaluated at 0. That's actually given. It's given where? It's given right here. That's equal to 250. We also know something else. We also know that y, let's try a different color there. We also know that y of 5 is equal to what? Is equal to 110 kilograms of the substance. And so you can see as time elapses, there's less and less of the substance. So this is actually a decay problem as indicated. Let's take some of this information and complete part A. Y of t is equal to y sub 0 e to the rt. And we already know what y sub 0 is. It's 250. So we have y of t is equal to 250. We have e. We don't know r. And t is our variable. So our goal here is to find r. How can we find r? So we're going to use the next piece of information. Well, the substance reaches 110 kilograms at a certain time. In fact, that time is actually 5. And now we get this equation, which is very, very useful. 250 is not 0, so we're going to divide the entire sides by 250. We get 11 over 25 is now equal to e to the 5 times r. We're going to take the inverse of the exponential function, which is called the natural log. And we're going to take the natural log of both sides of the equation. Now, we already know what's on the right-hand side of the equation. Remember, the natural log is base e, and so one of our log properties says this is just 5r. 5 is not 0, so we could divide by 5 to balance this equation. And finally, we get an equation about r. R is equal to what? Let's say natural log of 11/25 raised to the 1/5 power. Now, we want to find a relationship between y of t and t. So we're going to go back to here, right at the beginning. We'll go back to this very, very first line, and we're going to write a much better relationship. Y of t is equal to 250 e And R is what? R is actually the natural log of 11/25 raised to the 1/5 power, and multiply by our independent variable t. Or there's other ways to write this function. We could write it this way: y of t is equal to 250 e to the 1/5 natural log of 11/25, put that in a bracket, and multiply by your independent variable t. So either one of these would be acceptable. Let's use one of these functions to answer the question in part B. Part B says, how much of the substance is left 22 hours after the beginning of the experiment? That's really just saying, what's y of 22? I'm going to go ahead and use this function. And let's evaluate y of 22. 250 e to the 22/5 times the natural log of 11/25. So we could simplify this a little bit more. This is 250 times e, natural log of 11/25 raised to 22/5. Using log properties, we know this is 250 times the base of 11/25 raised to the 22/5. Now, if you're using order of operations, make sure you use it with the order of operations in your calculator as well. So you're going to have to do the exponent first here. So on your calculator, you would actually type your base, which is 11/25, and raise it to the exponent first. And doing that, you should get 6 and 7473 ... And it keeps going, but it says to round to the nearest whole number. So we're going to round this to, well, that's a 7 in the tens place. So that's more than 5. So we're going to round this to 7. 7 what? 7 kilograms. Now, if the problem is given to you in words, you should answer it back with words. So for part B, let's answer it this way. After 22 hours, there is about 7 kilograms of the substance. So even though I circled the key answers, what's more important is that you simply show all your work. So in some ways, you should just circle all your work here and make sure you could replicate as many of these steps as possible.